So microwave mediated reactions. இது வந்து நம்ம வீட்டில் கிச்சனில் மைக்ரோவேவ் குக்கிங் அவன் இருந்தனாக்கா இந்த reactions எல்லாம் we are doing every day. The microwave is produced by a device called magnetron, which is present in domestic microwave ovens and a special microwave oven manufactured for laboratory and industrial use. The electromagnetic radiations வந்து wavelength 1 millimeter to 1 meter. This is called the microwave range, that is 300 gigahertz to 300 megahertz. They are non-ionizing radiations. அது ஏரில் பாஸ் பண்ணாக்க அயான்ஸ் எல்லாம் ஃபார்ம் ஆகுது. Only polar molecules observe microwave and heat the polar solvent and the reactants. இப்போ போலார் வால்யூம் இல்லாமல் ஜஸ்ட் ஒரு கிளாஸ் டம்ளரை வச்சாக்க அது ஒன்றும் ஹீட் ஆகாது. தெர் இஸ் நோ பொலாரிட்டி, இட் வில் நாட் கெட் ஹாட். அது ஒரு 5 நிமிஷம் வச்சுட்டு எடுத்துட்டு கையில் தொட்டாக்க அது கூலாக இருக்கும். தி ஹீட்டிங் இஸ் டியூ டு டை எலக்ட்ரிக் லாஸ். அது வந்து எக்ஸைட் ஆகுது. அந்த எக்ஸைட்டட் ஸ்டேட்லேருந்து கிரவுண்ட் ஸ்டேட் வர்றது அந்த எனர்ஜி வந்து வெளியில் வருது. அந்த எனர்ஜி தான் தி எனிதிங் தட் இஸ் கெப்ட் இன்சைட், அதுதான் ஹீட் பண்ணுறது. Even molecules with induced dipole moment will absorb microwave. So either having dipole moment or induced dipole moment. Induced dipole moment na ஒரு molecule accidentally இன்னொரு moleculeோட பக்கத்தில் பாஸ் பண்ணாக்க அதில் ப்ளஸ் மைனஸ் இருக்கிறது, it will make the other one delta plus delta minus for a short time. அந்த molecule it will get heated. Heating by microwave is fast, selective with dipole moment molecule and induced dipole moment molecule. The waves couple at the molecular levels. What happens is there is a it takes the energy level from one point to another point by absorption of this microwave, and the relaxation to the ground state will emit the energy, and the reaction travels outside, unlike conventional heating where it goes from outside to inside. இது வந்து inside to outside heating. This is a reaction which leads to this. You have this ammonium ion, this trimethyl, this benzyl group, and this ammonium ion, if it is heated with water, it produces a polymer. It forms a double bond here, and that double bond results in polymerization. Whereas if you use this with chloroform and water with microwave radiation, it just forms the double bond. So it makes a lot of difference in the product. This reaction is reported in Australian Journal of Chemistry, 1995, year 60, the page number 60, volume 2456, the page number. This is JOC. ரெண்டு ஜேர்னலில் இது வந்திருக்கு. Australian Journal of Chemistry and the Journal of Organic Chemistry. The references are shown. If you have aliphatic alcohol, if you use it with a catalyst CrO2 and MAC-TRIV, that is a catalyst which is incorporating chromium oxide. If you use microwave at 5 to 25 mm, this gets oxidized to the corresponding aldehyde with a yield of 69 to 96. Conventional heating produces only 45 to 67. The MAC-TRIV is a catalyst incorporating chromium. Australian Journal of Chemistry and again Journal of Organic Chemistry. Sonochemistry. This is done by sonic radiation. You produce this is mediated by ultrasound. Ultrasound in the medical imaging use பண்றாங்க. stomach, kidney and other organisms. இந்த அல்ட்ராசவுண்டில் பார்த்தாக்க அதனுடைய சைஸு, ரேடியஸ் எல்லாம் தெரியும். இங்கே வந்து it is used for chemical reactions. Infrared frequency, IR it's called, or infrared frequency is less than 20 hertz, not audible. Audible to human ear 20 hertz to 200 hertz. And ultrasound, ultrasonic about 200 hertz to megahertz, it goes further. Ultrasound waves are produced by subjecting a nickel bar to an alternating magnetic field. That's oven that produces ultrasound. If you have this paramethyl phenyl acetonitrile react with toluene aluminum oxide in the presence of ultrasound using KBR, you have substitution of the cyano group to bromine. Normally only cyano group gets substituted to the bromine gets substituted to cyano group. If you have bromine here, it will become cyanide, but this is taking place in the reverse in the presence of ultrasound. And if you reacted with the aluminum catalyst, these two molecules get together, form this biphenyl type of molecule. This is called a Wittig reaction. You have a ketone reacted with CH2I2 zinc tetrahydrofuran. This is done with ultrasound. It very easily forms this double bond CH2. So, C double bond O gets to C double bond H2. Photochemistry. This is very early chemistry that was known for a long time. Whenever a reaction did not take place with heat, the other alternative that is tried always is shining light into the reaction. This is called the photochemistry. The wavelength and energy range UV light is 200 to 400 nanometers, which has an energy of 140 to 70 kilocalories. Visible light 400 to 750 nanometers with an energy of 70 to 40 kilocalories. Infrared greater than 750 nanometers, 40 or less kilocalories. Photochemistry deals with reactions resulting from absorption of visible or ultraviolet light by molecules with a dipole moment. The changes in the molecule on absorption of light is shown below. Chemical reaction can take place from either the S1 or singlet state or T1, the triplet state. We will look at the reaction. S is a molecule, H nu is the designation, it is shown for absorption of light. This S after absorbing of light, nu is the frequency, H is the Planck's constant, together it gives the energy. Now, it can become an excited singlet state. Singlet state means all the electrons are paired and it just absorbs the energy. From the singlet state it is excited, it has a higher energy because it is absorbing this H nu. From that it can come to 0, and this emission of light is called a fluorescence. It is usually the shorter wavelength, and then you have what is called intersystem crossing. This excited singlet state can become triplet state. Singlet state, you have a molecule this is the excited singlet state. The two electrons that I have shown are paired just like in the molecule which is before absorption of light. Then when it goes to the triplet state, the two electrons are parallel. Here the anti-parallel opposite becomes parallel. Here it is the total value of spin, half minus half equal to 0, 2 into 0 plus 1, that is why it is 1 singlet state. Here it is half plus half is 1, 2 into 1 is 2 plus 1 3, that is why it is called triplet state, 3 is 1 star. The triplet state usually has a longer lifetime than the singlet state, and when it emits light to form the ground triplet state, this is the excited triplet, this is the ground triplet state, it produces phosphorescence. That means it emits light over a longer period of time, and usually at a longer wavelength, because the energy of this is much higher than the energy of the singlet state. Now, the reactions that take place with this, you have a ketone, you excite it with light, you have N to pi star transition. That means N is the electron on the oxygen is given, that is there are two lone pairs of electrons. Electron from one of the lone pair gets excited and forms this excited state. The excited state has a single electron. It is not a single electron, it has a pair, but this is going to break like this. The molecule has the excitation energy here, but it is transmitted here and it breaks this molecule, and you have RCO dot plus R dot. These are two. This is called the Norrish type 1 cleavage, that it just cleaves the carbon to carbon bond, the carbonyl to carbon bond. Now, you have another type of reaction. You have this ketone which is excited, it produces N to pi star. That is the first type of transition that takes place. When you have orbital sp2 orbital or sp3 orbital which has an electron pair, it first that electron is transported to the pi star, the higher level. The pi level has two different energy, the pi level and the pi star level. So, the electron is transported from N to pi star, and the resulting radical abstract hydrogen from the carbon which is third carbon. So, the hydrogen is abstracted here, and this will come, and you have this product that is formed like this. The hydrogen will go to the oxygen, you have alcohol, and this double bond will come here. So, I have shown the bonding coming here, and the bond goes there, and you have this removal of this the propene, and forms this enol of acetone. This becomes a ketone, you get acetone. So, this is called the Norrish type 2 cleavage. First it gets to the N to pi star excited state, from there it goes to T1 triplet excited state. In the triplet excited state, it undergoes the chemical reaction of abstracting the proton from the third carbon and undergoing a rearrangement where this breaks off, the propene breaks off, and you get the enol of the acetone, it becomes the acetone, ketoenol tautomerism. There is another type of reaction. This is usually done with S into sigma star. So, from the singlet you have this ketone, there is double bond, it undergoes something like a rearrangement, not a rearrangement, cycloaddition. This bond goes there, this bond goes there. You have a 4-membered ring with oxygen present in it. Usually when you treat a trans olefin excited with light, you have the pi to pi star triplet, and this becomes cis 53% and trans 47%. The ratio of the two change. You have the pure trans, it becomes 53% cis and 47% trans, and you can, if you again irradiate it, you can get more cis and you can convert it almost to cis. This is another reaction with the double bond. This is called norbornene. Say 2,2,1 cyclo bicyclohexene. This double bonds with the absorption of light becomes n to pi star. முதல்ல n to pi star singlet, அதுக்கப்புறம் triplet. அது இந்த ரெண்டு electron will react with the 2 electrons with another molecule, form a 4-membered ring, cyclobutane ring, connecting the 2 norbornene rings. This is another very interesting rearrangement with photochemistry. If you have this dimethyl cyclohexenone, the double bond here, ketone 6-membered ring is hexenone, and the dialkyl hexenone, 4 dimethyl hexenone. If you shine light, and it becomes the n to pi star triplet, 2 electrons are separated, and from this the electron gets changed into 2. This electron gets demoted here, it becomes minus, and this becomes plus. The electron changes its position. You get electron demotion from higher energy state to the lower energy state, and from this the negative charge comes down to the oxygen, and then this comes down to this electron, this bond comes down to here, and this goes to here. So, this is the rearrangement that takes place, and when this attacks this, you get a 5-membered ring fused with a 3-membered ring. It's a very interesting types of reaction. This is called bicyclo 3,1,0 hexane. This is named as 1, 2, 3, 1. There is 1 carbon in the bridge, 3 carbons in the bridge, no carbon in this bridge. It is 3, 1, 0. There is 6 carbon atom hexane. There is 2 rings. It is called bicyclo hexanone. No. Conclusion. It can be seen from the above presentation, energy and environment are getting their due attention in conception and execution of chemical reactions in the laboratory and industry. முன்னெல்லாம் ஒன்றுமே ஐடியா இல்லாமல் எது லேபில் ஒர்க் பண்ணுறதோ அந்த ரியாக்ஷன்லாம் பண்ணி அதுலேருந்து ப்ராடக்ட்ஸ்லாம் பண்ணி கமர்ஷியலாக விற்கிறதுக்கு ஏற்பாடு பண்ணியிருந்தாங்க. இப்போது கமர்ஷியலாக ஒரு ப்ராடக்ட் மார்க்கெட் பண்ணுறதுக்கு முன்னாடி அதை எப்படி இது பண்ணுறது, டாக்ஸிசிட்டி, அதனுடைய என்வாயன்மெண்ட்டில் எவ்வளோ நாள் இருக்குது, பயோடிகிரேடபிலிட்டி, இதெல்லாம் வந்து கன்சிடர்ட் அஸ் அ ஃபேக்டர். இந்த cradle to cradle approach of tracing origin of all chemicals involved in the preparation and manufacture, the ultimate disposal, with a keen eye on their direct effect of polluting air, water, earth, and their subtle effect on ozone hole, climate change, and as at unrecognized effects are given lot of importance. So, the process development has become more difficult, more challenging. In the aspect எல்லாம் முதல்ல you have to see whether the chemicals used as a product or reactant, they are hazardous or poisonous, and அதை வந்து கண்ட்ரோல் பண்ண முடியுமா, அதை டிஸ்போஸ் பண்ணுறது எவ்வளோ ஈஸி, டிஸ்போஸ் பண்ணாக்கா அட்மாஸ்ஃபியரில் எவ்வளோ நாள் அது இருக்கும், இந்த கன்சிடரேஷன்ஸ் எல்லாம் ரொம்ப இம்பார்ட்டண்ட் இருக்கு. திஸ் இஸ் பிகமிங் மோர் இம்பார்ட்டண்ட் as a field now, as a separate field from regular organic chemistry called green chemistry. The text and reference book for this course is an insight into green chemistry by Bandyopadhyay C. Chandrakant, this is first name, Books and Allied Private Limited, second edition 2021, Calcutta. It comes from Bengal, and the author was very kind enough to provide me a textbook as an author's copy, and I hope you have some understanding of all the factors involved in making chemical reactions, chemical products safe for human use and also posterity, that we don't leave our footprint on the atmosphere, so that we are able to produce very safe type of compounds for commercial purpose. ரொம்ப நீங்கள் எல்லாரும் இந்த லெக்சர்லாம் கேட்டு உங்களுக்கு அது பிரயோஜனமாக இருக்கும்னு நான் நினைக்கிறேன். உங்களுக்கு ஏதான ப்ராப்ளம்ஸ் இருந்ததுனாக்கா எனக்கு வந்து யூ கேன் ரைட் டு மீ. அட் தி எண்ட் ஆஃப் தி கோர்ஸ் தே வில் கிவ் யூ ஆல் தி இன்ஃபர்மேஷன், எப்படி காண்டாக்ட் பண்ணுறதுன்னு இன்ஃபர்மேஷன்லாம் கொடுப்போம். ஸோ இது வரைக்கும் நீங்கள் இதை கேட்டு ஐ ஹோப் யூ ஹவ் பெனிஃபிட்டட். Let us see after this information is disclosed to you. Thank you.